All right, so MNIST is a well-known machine learning data set where you're attempting to classify handwritten digits. And recently I thought it would be fun to experiment with just the absolute simplest ideas, just as a kind of means to experiment and see what the results are. So in this video, I will talk a little bit about the concept of producing a classifier that uses the distance from a class mean as the way to classify something. And so what I mean by that is that um, you start out with a set of training examples for the handwritten digits, but what you can do is you can take all the digits that are a 0 and you can average them all together, or the ones and average them all together, and you can get kind of an average image. So for the digit 1, this is what it looks like. And what this is telling us is that there are some pixels in the center of the image that are extremely common. Almost all handwritten digits in the data set have black pixels here. But the higher up you go, the more variability there is, because depending on the angle with which you drew the one, it might light up these pixels or these pixels over here. But you can kind of get a sense of the envelope and so on. So if you produce these average images, then one technique you could use to classify the handwritten digits is that you would take a sample image that you want to classify, and then for that image you can compare it to all of the average images for these classes. And this is what you get for this particular handwritten digit, sorted from worst to best. So what we're doing here is we are taking, so in this first image, we're taking this average 0 and this particular 1, and anywhere that the pixel intensities aren't exactly the same, will have some intensity of white to it. So all this black here are pixels that were exactly the same color in both images, no difference. This really intense white, that's a pixel that was black in the 1, but was just about pure white in the average 0 digit. And so to get a rough sense of how similar or different these things are, you can then basically just, one way to say it would be how much white paint would you need to paint this image. And for the 0, it's a lot, especially because of this intense white here in the middle. But then as we scroll through here, 6 is getting better, 3 is yet better. 7 is the best incorrect answer, because the slanted stick of the 7 has some overlap. And the very best is 1. And that's what we were hoping for. So you can see the pixels here in the middle were strongly present in both our 1 and the average 1. And then where you get more discrepancy is up here at the top, where there's a lot of variability in the average 1. And then there's some really intense white where it was quite uncommon in the data set for a 1 to descend all the way down to this point, but our digit did, and so it kind of gets docked there. So in this case, the classification was correct, and we said that this was 1. So it's kind of just, obviously this is not going to be a high quality classifier, but it's an interesting experiment to run and just kind of see what happens. And so the moment of truth is, it's just curious what happens when you run this on the whole data set. And it's kind of fun to predict just intuitively what would you think the average accuracy would be on the data set. What digits do you think would fare pretty well and be classified accurately, and what digits would be quite challenging? So before I reveal the results here, there's one digit in particular that is much simpler to recognize than the other digits using this technique. It's almost shocking how accurately you can detect it. So take a moment and see if you can guess which of these digits would be the most recognizable. And let's have a look at the results. So that digit is the 1. And somewhat astonishingly to me, you can recognize it with 99.9% accuracy, which is pretty good. The overall accuracy is about 58%, which I think that makes a fair amount of sense. It's obviously horrible if you were wanting to do this in a high quality way, but if you ask me, it's actually surprisingly good given how simplistic this technique is. And then there are digits like the 5 here that are very, very difficult to discriminate using this technique. So if you were just to kind of roll a proverbial dice um, to see whether something was a 5, you would kind of expect to get a 10% accuracy. And this is almost double that. So it is better than pure chance, but um, pretty bad accuracy there. So that's it. I don't know if there's anything too overly profound beyond any of that about the experiment, but um, when you're just looking to play around and try the simplest things and see what happens, and if there's anything to learn, that's what results if you use just purely the distance from the mean with MNIST to do a classifier.